In this topic, we are going to learn about position vectors. The position vector OP is the position of a point P with reference to a fixed point O on the plane. What this means is that a position vector is always with reference to a point O. We usually label position vector OP as P and position vector OQ, for example, as Q. To find PQ, we can use this vector addition. And the common letters here that we can use will be, yes, the letter O. And hence, vector PQ will be equals to vector PO plus vector OQ, which will give us negative P plus Q. In this example, vector RS is equals to 3A plus 5B and vector OR is equals to 4A minus B. We are asked to find the position vector of S. What this means is that we are asked to find vector OS. Vector RS can be written as this vector addition. And the common letter here that we can use based on this example will be the letter O. And hence, vector RS is equals to vector RO plus vector OS. Since vector OR and vector RS are given, we can easily find vector OS by subtracting vector RO on both sides to give us vector RS minus vector RO to be equals to vector OS. Now, vector OR is equals to 4A minus B. Vector RO will be the negative of this vector, which will be equals to negative 4A plus B. Substituting this and vector RS into the equation, we can find vector OS. And opening the brackets, we will get 3A plus 5B plus 4A minus B equals to vector OS. Further simplification will give us the answer vector OS equals to 7A plus 4B. Next, let's look at what collinearity and parallel vectors are. What is the relationship between the line AB and CD if vector AB is equals to K multiplied by vector CD, whereby K is a scalar multiple? To simplify things, we will let K to be greater than 0. If the value of K is 1, then vector AB will be equals to vector CD. And yes, these are equal vectors, which means that the direction and the magnitude are the same. Since the directions are the same, it also means that these two lines AB and CD are parallel. If K is greater than 0, then these two vectors have the same directions, but they have different magnitude. And since they have the same direction, once again means that both vectors are parallel. Now for K less than 0, the direction will be the opposite direction, but both vectors are still parallel. In order to show that two lines are parallel, we need to show that the two vectors are scalar multiple of each other. Now, what is the relationship between points A, B, and C if vector AB is equals to K times vector BC? Once again, K is a scalar multiple, and we will let K to be greater than 0. If vector AB is equals to K multiplied by vector BC, then these two vectors have the same direction, but they have different magnitudes. Now, since there's a common point B here, AB and BC are parallel, and points A, B, and C are also collinear, which means that these 3 points lie on a straight line. We'll look at why this is so later on. To show that 3 points, for example, A, B, and C are collinear, we need to show that vector AB is equals to the scalar multiple of vector BC, or vector AB is equal to the scalar multiple of vector AC. As seen earlier, if these two vectors are equal, then these two vectors have the same direction but have different magnitude, and they are parallel. Likewise for this. Now you notice that there's a common point B here, and therefore AB and BC are joined. And hence, the points A, B, C lies on a straight line, or what we call collinear. When there are no common points and the vectors are equal, these two lines are parallel. If there's a common point, then these 3 points here are collinear. In this example, we are asked to state two facts about vectors PQ and JK. What we need to do is see whether these two vectors are scalar multiple of each other. We will start off with a larger number, let's say 3 here, and we'll see whether we can factorize out the vectors here. Is there a scalar that you can use to multiply this vector JK so that it will be equals to PQ? Yes, we can use the scalar negative 3, as negative 3 times negative a will give us 3a, negative 3 times 2b will give us negative 6b, and vector PQ will be equals to negative 3 times vector JK. This means that vector PQ is 3 times the length of vector JK, and these two vectors are parallel. Next, we are asked to state two facts about these two vectors PQ and PR. Similarly, we will start off with a larger number, let's say 4 over 5p here. And we want to see whether these two vectors are scalar multiple of each other. And therefore, can we multiply a scalar to vector PQ such that it's equals to vector PR? Yes, we can multiply it with 2, as 2 times 2 over 5p will give us 4 over 5p. 2 times 1 over 4q will give us half q. And we will have vector PR is equals to 2 times vector PQ. So the first fact is that vector PR is twice the length of vector PQ. And since there's a common point here, the points P, Q, and R are collinear. In this last example here, OABC is a trapezium. Vector OA is given to be A. Vector OC is equals to C. The ratio of AB is to OC is equals to 3:4. And vector OX is equals to 4 over 7 of vector OB. Now let us translate this information onto the diagram. OABC is a trapezium means that OC is parallel to AB. Vector OA is equals to A. We will write the letter A here with an arrow. Vector OC is equals to C, and we'll write the letter C here with an arrow. The ratio of AB is to OC is equals to 3:4, and we'll write the ratio here. AB over OC will be equals to 3 over 4. Since we have already found OC, we can multiply OC on both sides to give us vector AB is equals to 3 over 4 times vector OC. And vector AB will be equals to 3 over 4c. We'll write 3 over 4c here with an arrow. Okay, finally, vector OX is equals to 4 over 7 times vector OB, and therefore the ratio of OX over OB will be equals to 4 over 7. And we will have the ratio 4 here and the ratio 3 here. First, we are asked to express vector OB in terms of A, N, or C. And vector OB can be written as this vector addition. The common letters that we can use here will be, yes, the letter A, as we have already found vector OA and vector AB. And therefore, vector OB will be equals to A plus 3 over 4c. Next, we are asked to find vector AC. We can use this vector addition with the common points O, or we can use the common points B as well. Now, AO is negative A, and OC is C. Therefore, we will have vector AC to be negative A plus C. We are asked to find vector AX here. Using this vector addition, the common letter that we can use is, again, is either the letter O or the letter B. Now, AO has already been found, but we have not found OX yet. Previously, we have already found OB to be A plus 3 over 4c, and the ratio of OX over OB is equals to 4 over 7, whereby OX is equals to 4 over 7 OB. This was also already given in the question previously. Now, given this and vector OB, we can find that vector OX is equals to 4 over 7 multiplied by vector OB. To find vector AX, we will have AO, which is negative A, plus vector OX. And simplifying, we will have negative 3 over 7A plus 3 over 7C. Next, we are asked to show that the points A, X, and C are collinear. Since we already found AX and we have AC, we will use vector AX and vector AC. We will start off with a larger number regardless of the sign. Let's use 3 over 7 here. And we see whether these two vectors are scalar multiple of each other. And can we have a scalar multiple here such that AX is equals to K of AC? Yes, we can have 3 over 7 here. So that 3 over 7 times negative A will be negative 3 over 7A. 3 over 7 times C will be 3 over 7C. And this will give us vector AX is equals to 3 over 7 times vector AC. And this equation will prove that the points A, X, and C are collinear. In summary, a position vector OP is the position of a point P with reference to a fixed point O. And it is usually written as P. To show that two lines are parallel, we need to show that they are scalar multiple of each other. And to show that 3 points A, B, and C are collinear, we need to show that vector AB is equals to K times vector BC, or vector AB is equals to K times vector AC, whereby K is a scalar. And that's all for this topic.